Hey, I got about 40 minutes for you and then I'm out. $40 is less than 80. Let me remind you that. So I got about 40 minutes of stuff to get through. Okay. This idea that we're going to be doing today is probably the hardest thing in chapter 7. So recall last time in 7.1 we talked about using the law of sines and cosines. In 7.1 we discussed how to use the law of sines in the ASA and AAS cases. What we haven't done yet is the SSA case. That's going to be today. So I'm going to start by drawing a triangle and labeling it using our standard labeling convention. And I'm going to kind of just highlight in my SSA situation. So I have an angle, an included side, and then the opposite side. And I'm going to introduce a little bit of notation, a little bit of naming here for the SSA that'll make communicating what's going on a little bit easier. So I'm going to call the green here, the angle, the GA, standing for given angle. I'm going to call the blue side the OS, standing for other side. And the yellow, I'm going to call the SOGA, which is the side opposite to the given angle. So just so we have some names for these pieces. Okay. It makes it easier than trying to do it in letters, because depending on how you name your triangle, like that'll be different when you go to try to use the formulas and do the checks. It gets confusing, so I'm just going to name the parts with like words instead of like a symbol. Okay? All right, so unlike the ASA or AAS cases where, as within reason, no matter the angles you choose or the side lengths you pick, there's always just one triangle possible. As long as your two angles aren't more than 180 degrees together, any numbers you pick for your two angles and your side will work for ASA or AAS. That is not the case for SSA. So with an SSA triangle, we can, let's say givens, we can have 0, 1, or 2 triangles possible. So what that's saying is that when we ask to solve an SSA triangle, might not be possible. I might get one set of answers or I might get two set of answers. The first thing that I want to talk about here today is how to predict which one of these three situations we're going to be landing in, right? So I know, like, is there just no solution to this? Is there one set of answers or is there two set of answers? Okay with that plan? Okay. So the first situation is when the given angle is not acute. So it has to be bigger than 90, bigger to or equal to 90 degrees. So in that situation, if we check, or if we, all we have to do is compare the SOGA, the side opposite to the given angle, and the other side, and that'll answer our question here. So if we have a non-acute angle given to us, and the opposite side is at least as big as the SOGA, no triangle is possible. Now, if you think back about this, you remember we talked about in 7.1 how the side lengths and angle measures in a triangle are proportional, that the biggest side has to be across from the biggest angle. So if our given angle is not acute, it's 90 degrees or bigger, it has to be the biggest angle in a triangle, which means that the SOGA would need to be the biggest side. If it's not, there's no way you can put this thing together and still get a triangle out of it. So that's why there's 0 triangles there. So that's fairly cut and dry, right? All you need to do is check the size of the angle and then compare the two sides. So the other case is when the given angle is acute. That is when it's less than 90 degrees. So if, oops, that's not what I wanted. So if the other side is bigger than or equal to the SOGA, then we have one triangle. If this, oops, I'm sorry. That's the wrong way. So if the other side is, yeah, if the SOGA is the bigger of the two, there's one triangle. If the SOGA is the smaller, though, it's not clear what's going on initially, at least from the given information. We can't tell right away. Because we can't tell immediately, we call this the ambiguous case. So what we'll do now is we'll talk about how to figure out what's happening in the ambiguous case. Okay? So that's the bad scenario. That's the scenario you're hoping not to have to encounter, because it's the one that with the least clarity. So what we'll do is we'll start with just kind of an example problem, and we'll develop the tool that we need to use to figure out what's going on based on our example. So we're told we have a triangle. P is 50, angle P is 56 degrees, side P is 16, side Q is 19, and we want to try to figure out how many triangles are possible. So I'll start by drawing my triangle, and I'll label my sides using our side naming convention that we've discussed. So I'll draw in my given angle. Oh, I should label, or I should add in my givens, right? I have my one side and my other side. So I can see that this is an SSA triangle. I can see that the given angle is acute. I can see that the SOGA is less than the other side. So that's telling me this is the ambiguous case. Is everybody okay with my analysis to this point? So to try to determine if it's 0, 1, or 2 triangles, I'll start by just kind of setting up a law of sines. Now I notice that I have angle P and side P, so I'll use that in my law of sines. And the only other piece of information I have is side Q. So I'm going to have then sine of angle Q in my other half of my law of sines. Is everybody okay with how I set that up? So that kind of equation is called what again? Proportion. Great. And how do we solve a proportion? We cross multiply. And then we'll divide by the 16. So the sine of angle Q is by itself. And it turns out that this number here, that is going to be what I need in order to tell what's going on, whether there should be 0, 1, or 2 triangles possible. So in general, what this is it's the other side times sine of the given angle divided by the SOGA. So depending on the number I get here, this will tell me whether I have 0, 1, or 2 triangles. So if that number is less than 1, it's 2 triangles. If it's equal to 1, it's 1 triangle. When I say equal to 1, I mean dead on equal. Like 1.05 is greater than 1. 0.999 less than 1 has to be dead on 1. And if it's greater than 1, that's going to be 0 triangles. So anytime you stumble into the ambiguous case, you go straight into that formula to tell yourself, how many triangles are we looking for? So let's check now for ours. We have 19 sine 56 divided by 16. And I get 0.984. Since that's less than 1, that tells me I have 2 triangles. So far, so good? Yep. So I'm going to continue this problem now and show you guys how we solve for the 2 triangles. So my process for doing this is going to be basically the same as what we did before to solve the triangles. I'm going to find, the 3 missing pieces of information. I'm just going to have to do that twice, one for the first triangle and one for the second triangle. So solving for the first triangle, I'm going to just borrow this information that I had already started. That sine of angle Q is equal to 19 sine 56 over 16. And now I need to get that I need to get that angle Q out from trapped inside of that sine, right? How do I get that angle Q out of there? How do I get rid of that sine that's stuck on the front? Nope, because sine isn't a number, so you can't divide by it. It's going to cancel that sine out of there. What's that?
Put it over 1 and then multiply by yourself.
Nope, because it's not a number. What's going to cancel it out of there? What? Not factoring. What's that? Yeah, sine inverse. Sine inverse is what we need to do. So do sine inverse of both sides. And now I'm going to introduce a little bit of notation here. Since I'm going to have two answers for angle Q, one for each triangle, I'm going to put a little subscript on my angle Q. I'm going to call this one Q1, so I remember that this is the angle Q for the first triangle. And then I'll find angle Q for the second triangle a little bit later. I'll call that one Q2. So I'll just go to my calculator now, start typing this in. So I get about 79.9. I'll box that up because that's one part of my answer. But I'm also going to highlight this because that answer is going to be important later and I don't want to forget about it. So I'm going to highlight that one too so I remember to, when it's time to look for triangle 2, I'm going to need that answer. So far so good? So now I have angle P and angle Q. So that's going to allow me to get angle R for free, because I have now 2 of the 3 angles. Right? Notice that I'm not putting a subscript on angle P. Angle P is a given. Angle P is a part of both triangle 1 and triangle 2. So I get 44.1 for angle R1. Everybody okay to there? Now that I have angle R, I can solve for side R. So again, I'll start with sine of angle P over side P equals sine of angle R1 over side R1. Oops, let me write in the number for angle R1. So far, so good. I'll then cross multiply and divide to solve this proportion. So I get about 13.4 for that. So those are my answers for triangle 1. So what I'm going to do now is I'm going to make a second column, and I'm going to do my work for triangle 2 over in that second column. In my experience, students that have problems with this are often have problems because of organization. Their work is kind of all over the place. They get confused about like, what triangle am I in? Like, what am I doing? So like, I'm going to try to be neat and organized as best I can. I'm going to label things with 1s and 2s. I'm going to do my work like one triangle at a time, so I don't, rather than hopping back and forth. I'm going to do my best to try to stay organized on this. So remember how we highlighted Q1? The reason I did that is because I'm going to use Q1 to find Q2. So Q1 and Q2 are always going to be supplementary. Okay, that doesn't mean that every angle in triangle 2 is supplementary to the corresponding angle in triangle 1. No, 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 no. Only the first angle you solved. So if I tried to do this starting with R1 instead of Q1, you get the wrong answers. Has to be the first angle you solve. The angle that's opposite the other side, the OS. So when I type that into my calculator, I get that Q2 is about 100.1. Now I have two angles in triangle 2. I have P and Q2. That means that I can get R2 basically for free. So R2 is going to be about 23.9. So far, so good. The last piece remaining for triangle 2 is side R2. I'll solve that the same way that I did in triangle 1, except I'm using angle R2 instead of angle R1. So if I cross multiply and divide, so I get about 7.8. What do you guys think? It's not too bad, right? It's really just a double version of the previous problems. The hardest part is recognizing when you're going to get 2 answers as opposed to 1 answer or 0 answers. That's usually the hardest part once you've identified, okay, this is a 2-answer problem. Finding the 2 answers is usually relatively easy. Let's do one more example. Just to make sure we got it. All right. So why don't you guys start drawing the triangle, filling things in, labeling, figuring out if it's an SSA case, if it's an ambiguous case, kind of start on that. I'll give you guys a little bit of a head start, and then I'll catch up, just to let you guys have a little bit of practice on your own before I start filling it in for you. Give you a minute or two to kind of start in on this, and then I'll come racing behind you, and we'll catch up and finish, about the same time. Or not, maybe I'll still beat you. Or maybe you'll beat me. Who knows? Sure. So I've drawn my triangle. I've identified that it's an SSA case and labeled in my GA, SOGA, and OS. I noticed that my GA is an acute angle, and my SOGA is less than my OS. So this is the ambiguous case. So then I'm going to do my formula. To see what's going on. So I get about 1.88. I notice that's greater than 1. What does that tell me then? There's no triangle possible. So even if I asked you to solve the triangle here, what would your answer be? No triangle possible. Nothing to do. Oh! Yeah. All right. That's all right. I don't mind that, right? So some of the time, yeah, okay, I get stuck doing a double problem with the SSAs, but sometimes I'm going to get a freebie where there's nothing to do. Okay. It's a little bit better news there. I was a little disappointed when I thought I was going to have double problems every time here, but I see sometimes it's no problem at all. All right. All right. I'm good with that. So this is where I want to stop today. So for next time, I'd like you to work on 5 through, is it 14 or 15? I forget. 14. So what is due Sunday?
1 through 4.
1 through 4. When is 5 through 14 going to be due?
Next Sunday.
Not next Sunday.
2 Sundays.
3 Sundays. Right, the Sunday after we get back from break. Nothing is due the Sunday before we get back from break, right?
Right.
If you have this Sunday off, enjoy your vacation. Don't worry about your math. 1 through 4.
1 through 4.
Okay. Yes. I want to point out just a couple of things on the directions here for this homework. Look at the directions for 5 through 10. What does the directions say?
I don't know.
It says, are 0, 1, or 2 triangles possible? So all you need to do is that initial analysis. You do not need to solve the triangle. Just do enough to say if there's 0, 1, or 2. That's pretty easy.
So 1 through 4 is due this Sunday. And then one's 5 through 10 due?
It's 5 through 14.
14.
It's the Sunday after we get back from break.
Okay.
No.
It's also on the My Notre Dame.
Can I take my phone out to stand in the
Now, if you read the directions for 11 through 14. It says 2 triangles can be formed. Solve them both. Here it's telling you these are all 2 triangle situations. Should you still start by doing the analysis to verify it's a 2 triangle situation? I would recommend you do that so you get used to the process. But they are guaranteed to be 2 triangle problems. Okay? That's this homework set. I'd like to remind you guys also about 2 other things. On Monday, on your My Notre Dame, there will be an announcement that publishes that will be titled like End of Semester Survey or something like this. All it is going to be a link to a Google form to fill out to whether you want a doubled high test score or to do a test retake. The Chapter 5 test that I'll pass back here in a moment was your last test for the semester, so you should have all the information you need to make that decision. Everybody okay there? And then for any of you guys with late or missing works, for chapters 2 through 5, the last day to turn any of that stuff in is going to be the Friday after we get back from break. Okay? If it's not in by Friday, I'm not taking anything from chapter 5. Okay? So if you're behind and you're like, ooh, I need to catch up on that someday is coming. Real quick, here's your deadline for the someday. Okay? Everybody's cool?
I've got a couple.
Yes, sir.
Yeah, please use the restroom.
Sure.